In how many ways can Anne be Cam, Don, Ella? I love these names. Anne, B, Cam, Don, Ella, and Faye. In how many ways can they be seated if they are given some restriction here? It says if Anne and B cannot, so this is very important, cannot, let me change the color here, cannot be seated next to each other. So this is very, very important here. So again, let's go through the question again so we'll see how the whole thing goes on. It says in how many ways can Anne, B, Cam, Don, Ella, and Faye be seated if Anne and B cannot be seated next to each other? Alright, what we're going to do now is I'm going to do away with the NN, the EA, and all these things. Let's just consider the first term here, the first letter we have here. So it's like saying in how many ways can A, so this is A, B, C, D, E, and F. So the way I got the F here is I'm considering the first letter you have here. So even the question itself, the way it was framed, is like it gave us a clue on how to start the question. So it says in how many ways can A, B, C, D, E, and F, in how many ways can they be arranged such that A and B must not be together? That is, they must not be together. So that's the question that we have here. Now how do we go about solving a question like this? Alright, now assuming there was no restriction, let's say, let me write the question down here. You have, maybe you are just told to find in how many ways can A, B, C, D, E, F be arranged. Now assuming we were not given any condition here, so my question is this. Assuming the question was framed this way, if it says in how many ways can the letters A, B, C, D, E, and F, in how many ways can they be arranged? Now we've gone through a problem like this. The number of letters you have here, you have 1, 2, 3, 4, 5, 6, and then so the number of ways of arranging these 6 different objects is going to be 6 factorial divided by, so how many times does A appear? 1 time, so that'll be 1 factorial. How many times does B appear? That'll be 1 factorial. How many times does C appear here? That's 1, so that's 1 factorial. So the same thing for the rest, 1 factorial and then 1 factorial. So 1, 1, 1, they are all 1. So anyway, our answer is just going to be 6 factorial. And then 6 factorial is 720 ways. So without restriction, the number of ways of arranging the word A, B, or arranging the letters A, B, C, D, E, and F without any restriction now is going to be 720 ways. Now, to answer this question, before we come to this question, I want you to reason this way. So you recall your probability that assuming you are given an event, let's say you have an event, say an event E. Now we know that the probability of an event E plus the probability of the complement of the event E happening. So the complement of E, we know this is going to be 1. So you recall from probability, if you're told to find the probability of something, the highest value of the probability of an event, the highest it can attain is just 1. So, and then you also know that if you're given an event, or maybe an event occurred, and then you're told to find the probability that the event occurred, and then if you sum the probability of the complement of the event occurring, the answer you can get is 1. Now let's go back to the question. What we have here is, it says find the number of ways of arranging A, B, C, D, E, F if A, B must not be together. So there are 2 things happening here. If A, B, so I'm going to use, let's have it here. So if A, B AB, if AB must sit next to each other, AB must sit next to each other, So we can call this an event E. Let's say this is an event E. Then the complement of this, that is if AB must sit next to each other, then you can guess the complement of this is just going to be what? It's just going to be must not sit next to each other, right? That's going to be AB must not. So must not now, must not. Let's just put out something here. Must not sit next to each other. So this is just going to be the complement of what we have. What we have here is going to be E complements. So the event is, if an event was AB must sit next to each other, then the complement of the event is just going to be AB must not sit next to each other. So the thing is, for the question we have here, we're told to find the number of ways such that AB must not sit next to each other. Now what we are going to do is, I'm going to use what I did here as a paradigm. So the probability 1 here simply implies when there is no restriction. Then E complement is when they must not sit next to each other. Then E is when they must sit next to each other. So let's write this in a layman's word, in words. So this says that, so I want to transcribe these statements here. So for E is the number of ways, so let's write that the number of ways of arrangements such that AB must sit next to each other, So this is representing E, like we have here. So this is representing E. So this is for E. Then for E complement, so it's going to be plus. So if E is must sit next to each other, then the complement is going to be must not. So this is going to be number of ways of arrangement such that AB must not sit next to each other, to each other. So this is for must sit, then this is going to be the complement, that is E complement. So that is that. Then this is just going to be equal to, so we said our 1, this is when there are restrictions, you can see. Then our 1 is going to be the number of ways such that there are no restrictions. So this is going to give us 720. So I do hope you see the paradigm that has been described here. So I use this as a model to form this statement here. But what the question asks is must not sit next to each other. So what we want to find is, we want to find this. This is the statements that we want to find. We want to find this. So but then the thing is, if I can find this, when I find the number of ways of arrangement such that AB must sit next to each other, so to find this, all I need to do is just deduct whatever I obtain here from 720. Just solve this equation anyway. Alright, let me now explain. I want to explain how we can find the number of ways of arrangement such that AB must sit next to each other. Let me explain that. So you know you have A, you have B, you have C, D, E, and F. You want to arrange these 5 items. There are 5 items you have here. So you have 6 items you have here. Now, but then if it says AB must sit next to each other, if they must sit next to each other, that is AB must sit next to each other, it's as if you have to treat AB as a single element, as if it's one. Then it's going to be, so here you have 1 2 3 4 5 6. Here you have 6 items or 6 objects, but here you have, based on the restriction, you have C, D, E, and F. So the items you have here, they're going to be 5 items because you've been told that they must sit next to each other. So that is to say, any arrangement you make, A, B must always be together. So it can be here, it can be here, it can be here, it can be here, it can be here. You understand? So now the thing is that, how then do you find the number of ways of arranging A, B such that they must sit next to each other? Now this is the idea there. Since we know that the number of ways of arranging, because they are all different, you can see this is A, B is different, C is different, D is different, E is different, F is different. So the number of ways of arranging this object is going to be, so the number of ways is just going to be, how many objects do we have? We have 1, 2, 3, 4, 5. So that will be 5 factorial, which is 120 ways. Now this is the number of ways of arranging these 5 different objects. But then, and that is because A, B must be together. But then the thing is this, let me show you something. This is one arrangement. If you have say A, B, you have C, D, E, F. This is one arrangement. And then you also have B, A, then C, D, E, F. Now for this arrangement, you'd observe that A, B, they are still in position 1, but then you can still shift AB and you can shift BA. So that's to tell you that for each of the 120 ways, there are also 2 extra ways. There are 2 extra ways of arrangement. So again, let's explain that again. Normally, if you have, for example, if I just give you let's say BAC or something like that. These are just 3 objects. If I told you to find the number of ways of arranging BAC, so since you have 3 objects, the number of ways of arranging BAC is 3 factorial, which is 6. So that was what I did here. The number of ways of arranging 5 objects, because we treated A, B as if it was a single entity. So A, B, C, D, E, and F, they are 5 objects. And then the number of ways of arranging that is 5 factorial, which is 120 ways. Now, but then you observe that this AB that we have here is a conglomerate of 2 different objects. So that is to say, we're only told that AB must be together, but we're not told that A must always be in front. So note, it just says AB must be together. So since we're not told, or we're not given under restriction that A must always be the first, or probably maybe B must be the first, then that simply implies that we need to consider the case when A is the first and B is the second for each of the arrangements. You understand? And then, since A can either be here or B can either be here, so that is to say that for each of the 120 ways of arrangement, you would also have 2 extra ways of arrangement. So that's to tell you that the total number, that is the total now, the total is just going to be, the total number of arrangements is going to be 2 times 120. That will be 2 times 120, which will be 240 ways. So that's going to be total number of arrangements if A, B must sit next to each other. So now we have here to be 240 plus, so let's say what we have here is X, then equals 720. So we want to find the number of ways such that they must not sit next to each other. So to find that, so we want to solve 240 plus X equals 720. So that tells us that X must be, so we subtract 240 from both sides. So it's going to be 720 minus 240, and that's going to give you 480 ways, right? So the solution to the problem is 480 ways. Yeah, so that completes the problem. So again, if all we just talked about here, if you feel you do not understand, then it might help if you watch this video 2 or 3 times. I'm very sure you would understand that when you watch the video. Yeah, thanks for watching.